All right, so I hope everybody's having a good day. Yesterday we did finish up the notes, and I went ahead and introduced the even and odd identities, as well as the cofunction identities. Remember, there was only two even trig functions, cosine and secant. The negatives basically disappeared. For the odd, the negative can be pulled to the front. And then we have the cofunction identities, which really won't be as important to us right now, but in a couple of sections when we look at the sum and difference, that'll play, a bigger part. But very quickly, last week on Friday, I did go ahead and assign this here. It was tangent of theta times cotangent of theta minus cosine squared of theta. I gave you this problem over the 3-day weekend to go ahead and simplify to one trig function. So if you were absent yesterday, please make sure to go ahead and turn that in so that I can get that taken care of. All right, now before we go ahead and move on with our lesson, we have a focus activity. Let me pull this up right here. Okay. And then once this is done, we will go ahead and turn them in, and we'll see what happens. Okay. So let's see here. Number one, a rhombus has diagonals of length 10 and 6, okay, as shown here. So these are being bisected by the diagonals themselves, and that's one of the characteristics of a rhombus. Find the smaller angle of the rhombus. Okay, so we're trying to find this angle theta right here. Okay. Now, let's see. We've already got a right triangle formed. Let me go ahead and highlight this. Okay. So we're talking about this guy right here. So we're trying to find theta. Now, the nice thing is I've already got two sides, and they happen to be the legs. So we have the opposite, and we have the adjacent. So what trig function could be used to help me here? Okay, it's going to be tangent. Okay, we could say that tangent of theta is equal to 3/5, right? Okay. Now, normally what we would go ahead and do, we're going to take the inverse. We're going to rewrite this because you evaluate a trig function at an angle measure and you get the ratio of the sides of a triangle, right? So if you're given the ratio, tangent inverse of 3/5 would give me theta. Okay. Well, let's go ahead and run through the Pythagorean theorem real fast because there's something happening tomorrow. What am I referring to? Okay, it's going to be the exam. Now, remember, the exam is going to be half those expressions that we've been working on, just simplifying those. And the other half is going to be coming from these inverse trig functions. And they basically fell into one of two categories. Either it was going to end up being a special right triangle, in which case we would be able to give the angle measure. If it wasn't, then we would go ahead and measure with a protractor. Okay, so let's see what happens here. Let's say we want to figure out what that radius is. So we've got r, 3, and 5. So let's go ahead. R squared is equal to 5 squared, plus 3 squared. So 5 squared is 25. Okay, 3 squared is 9. What's 25 plus 9? 34. Okay, so r would be the square root of 34, right? And then 34 itself is, 17 times 2. So that's not going to simplify. So let's say square root of 34. Okay. Well, is it one of my special right triangles? No, it's not, unfortunately. So if I wanted to, I could go ahead and measure this out and use my protractor to see, how close I'm going to get, which is what you'll be doing on one problem tomorrow for the exam. For this one, I think I'll just go ahead and type in the expression. If it turned out to be a special right triangle, great. If not, here we go. So I'm going to go ahead and see from the tangent button here. Oh, it's doing it again. So tangent inverse. Let's escape out of that. There we go. What was it? 3/5? So 3 divided by 5. Now mine's in degrees. So there we go. 30.96. I would probably feel comfortable doing what? I'd say 31, yeah. Okay. So I'd say theta has got to be about 31 degrees. So this angle right here. Now, would anybody like me to go ahead and create a coordinate system real fast? kind of measure it out and see if we actually get close to 31 on the protractor? You do want to see it? Okay. So let's see here. Let me come on down here. So let's see. What quadrant should I be focusing on if I'm going to do this? Remember, tangent inverse is going to be restricted to quadrants 1 or 4. So which one you say, Brand? Why the first? Because it's positive. Remember, look at the ratio to tell what you're going to be needing. Okay, so I'm going to put this in quadrant 1. I'm going to need a couple of things here. I'm going to need the ruler, okay, which it conveniently put at the very top of the screen. Okay, and I'm going to need the protractor. So let me get a protractor here. And again, conveniently puts it at the very top of the screen. Okay. Good. So I've got my measurement tools. Now we're wanting to recreate this right triangle, but the nice thing is the legs are 3 and 5. Okay. If they're not exact measures, remember we went ahead and put them in the calculator and then multiplied by what? 10, because we were going to convert it to millimeters. It gives us a more accurate measure. Well, here, okay, we needed 5 by 3. I believe the height was 3, if I'm not mistaken. Yes. See, the horizontal is 5 and the height is 3. So along the x-axis, I'm going to measure, start here. So let's say 5 is right here. Okay. And then from that, I'm going to go ahead and measure 3 up. So let's say 3 is right there. Move him over to the side. And from the origin, I'm now going to go ahead and put a line right through that mark that I made. Okay, so hopefully, as soon as I measure this, we're going to get close to 31. Let's see how we did. So how do I use this protractor here? There you go. That crosshair is right there. I'm going to put that directly on the origin. Okay. So let's see. Looks like mine is right on 30. So I'd say that works out perfectly. There you go. There you go. Thank you. Thank you, sir. Thank you. Thank you. All right. So now remember, the one on the test in which you're measuring using the protractor, I'm going to go ahead and give you a leeway of how many degrees? 5 degrees. So I'm going to go ahead and find the exact value, and then I'm going to go ahead and give you above 5 and below 5. All right. Okay, good. Brandon, is that good, sir? All right. So that did work out very nicely. So that is number 1. And let's see what number 2 says. A rectangle is 9.2 meters by 3.8 meters. What angle does the diagonal make with its long side? Okay, so let me go ahead and get a rectangle here. Okay, there we go. So it's 9.2 by 3.8, so 9.2 by 3.8. Okay, I'm going to go ahead and draw a diagonal. Okay, just like that. Now, what angle does the diagonal make with its longer side? So I'm looking for this right here. Okay. Looking for that right there. Is everybody okay with that? Okay. Well, what are some characteristics of a rectangle that's going to help me out here? Yeah, opposite sides are always going to be not only parallel, but also congruent. So if this is 3.8, this is 3.8 as well. And see, I've got my right triangle. In fact, we can go ahead and use the same trig function because from theta's perspective, we have the opposite and the adjacent, right? But what can we use besides tangent? We could use cotangent because it uses the same 2 sides. So I'll leave it up to you guys. Would you like to use tangent or cotangent? Tangent, okay. So this would be tangent of theta is equal to the opposite over the adjacent. Okay. So now if I want to work backwards from the ratio to find theta, I'm going to say tangent inverse of 3.8 over 9.2 is equal to theta. Now, while I'm thinking of it, because the test is tomorrow, is there any other way that I can show you inverse besides putting that little -1? There you go, arc. Remember, if you use the word arc in front of a trig function, like if I were to go ahead and say arc sine, that's the same as sine inverse of x. That arc is just another way of writing it. So I could have written arc tangent. Okay, so if you see that, remember it's just referring to the inverse. All right, so on this one, yeah, let's just go with the calculator. I'm going to come on over here. Let's see if it does it again. Hey, it did not. So there you go. Tangent inverse, what was it? 3.8 divided by, what was it? 9.2? Okay, 9.2. All right, so anybody help me out? What do I get when I push enter? Okay, so I'd say about 22.4 degrees. Okay. So let's say theta is about 22.4 degrees. Okay. Now, what can I do if, say, I wanted this in radians? Mm-hmm. There you go. If you want to convert degrees to radians, multiply by pi over 180. If you want to go from radians to degrees, 180 over pi. You're just flipping that ratio. Okay, good. Any questions on the focus activity? All right. Well, let's do this. This was focus activity number 3. So let's go ahead, get those 3 stapled, and let's go ahead and turn them into the tray. All 3 focus activities. Now, if you have lost or misplaced one, excuse me, there should be some right over here by Christian in the filing cabinet. Okay. Oh, since you just came in, just turn in what you have. That's fine. Thanks, Lexi. All right, good. While you guys are doing that, I'm going to shut this down. I'm going to save changes. Yo. Number 2, it should be right over here in the filing cabinet, sir. I don't remember what day I gave it, though, so you might have to look. And if you don't happen to have the focus activities, just try to get those to me as soon as you can. Okay. Okay, good, 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 good. So like I said, if you don't have those ready, try to get those to me as soon as you can. When I come in on Friday morning, I am going to go ahead and submit all the progress reports because it is already the 3rd week of the 6 weeks. Things are moving pretty quick. But I believe I mentioned this yesterday, but I'm going to go ahead and do so just in case. Did I say that I wouldn't be here on Friday? Yeah. Yes, okay. So I am going to, you won't be here either? Oh, you will be here. No, I will not. Oh, so you will not be here. Okay, there you go. So the plan for Friday, as you know, I'm going to a workshop. I believe it's from 9 to noon. So even if, I'm able to get out a little early, probably not going to be able to make it back in time for class. But I'm going to come in Friday morning, so I'm still going to have tutorials because I need to wait and see if my substitute's going to show up. She has signed on, so hopefully, that'll continue for the next couple of days and she'll be able to make it. But I'm going to leave with the substitute the assignment over this current lesson. I believe we started talking about that yesterday. Okay, so you'll have the whole period to work on that Friday. It'll be due on Monday, so when you come back, we'll talk about it, answer the questions, and then we will move right along with the next lesson. We might even answer some questions on the test if you guys are wanting to do that as well. But the only reason I would be here on Friday is if for some reason the sub didn't show up, but we will kind of see. You never know what's going to happen. So that is the plan as of right now. Any questions on that? Nope, 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 nope. Okay. Well, with the test coming up tomorrow, I wanted to go ahead, have a focus activity that kind of reminded you about inverses, okay? I also wanted to go ahead and give you this sheet that I found. It's a pretty cool little sheet. It's got 26 expressions here, and you've got all the letters of the alphabet, but each one of these is an answer to one of these expressions over here. Okay, so I'll go ahead and work a few with you to kind of, get the ball rolling. But the reason I liked this one was because it was something different. If you go ahead and answer every question correctly, you can use the assigned letter for that number and decode a secret message. And it has a nice little pun, and you guys know I'm somewhat fond of puns. Okay, so that's why I really took to this one. But for the bigger picture, I'm going to give you the rest of the period to go ahead and work on it. If you bring it back tomorrow completed and you correctly have the secret message decoded, that is going to be your bonus on the test. Okay? What's that? I'm going to make it 10. So you could have a 110 on there. I'm not interested in the, well, let me take that back. Because some of them, like for example, you really won't have to show any work. Like for example, 1 over cotangent. What would that be? Yeah, that's just tangent. So do we have an answer that is just tangent? Which one is it? Okay, V. So there you go, right there. Like there's really no work to show. On some of them, probably not a bad idea. Okay, like maybe on some of these, like maybe 7, 8, you might have 1 or 2 steps, but looking over this paper, I don't think that you're going to have any humongous expressions to simplify. Okay, so yes, sir.
So is this like what the test is going to be like?
It's going to be half and half. And remember, there's 11 questions, 10 of which are multiple choice, but half the questions will be simplifying expressions very similar to this. The other half was going to be what again? I keep forgetting. The inverses. Okay, so you'll be simplifying inverses to get either a special right triangle or you'll be using a protractor on one for sure. Okay, so do you see any problems on here that you'd like to start with together? 26. He lied. Maybe. You want to do 26? So I will work 3 problems with you guys. So this is one you want. Okay, 26. 26 it is. Well, does anybody notice anything? It says 3 times sine squared of x plus cosine squared of x. The answer is simply 3. Why? There you go. Remember, we have an identity, the sine squared of x plus the cosine squared of x equals 1. So I'm going to replace this with 1. 3 times 1 equals 3. Nope, we already did 1. Okay. All right. So now, what is, let me look back over here at my answers. What letter is 1? I? Oh, 3. I'm sorry. 3. You're right. Okay, so 26 is I. So that means everywhere here you have a 26. I'd want to put an I there. And let's see, we got another one here. Am I missing any 26s? Where's another one? No? I don't think I got them. Okay. There you go. So, Brandon, you're okay with the... Okay. All right, now, second problem. Brandon's on. I don't want to choose you.
23.
23? You guys want to do 23?
Yes.
Okay. So let's try that one. We got sine of x minus cosine of x, and this is all over sine x cosine x. Okay. Now, can I just go ahead and cancel the sines and the cosines? Now, if it was a product over product, absolutely, the answer would be 1. So, ideas. Take the reciprocal. No. I mean, we could take the reciprocal of the trig functions. Like, we could write the sines as 1 over secant. The cosines is, 1 over cosecant. The cosines is 1 over secant. I think that might make it a little more complicated, though. No, because we don't have, like, sine over cosine. There's something I would do. It's not in identity that you're noticing here. I would say it's just something using algebra. So let me kind of help you out with this one. Because here's my first idea. And like I said, are there going to be more than one way to do this? Absolutely. Okay, well, let's say you need to add or subtract 2 fractions. You have to have a what? You have to have a common denominator, right? So you remember when we used variables? I could probably illustrate this better with variables. Let's say I had, like, I don't know, x minus y, and that was all over z, right? Okay. Well, in order to add or subtract them, you have to have a common denominator. But in mathematics, a lot of what we do is reversible. So I could go ahead and separate each of the numerators over that denominator. So I could say x over z minus y over z, right? And if I were to do that here, that would allow me to do something. Okay. Right, Rhett? Right. Okay. So let's go ahead and do this with these 2 trig functions. I'm going to say sine of x over sine of x times cosine x minus, because we're subtracting. Then I'm going to put the cosine x over the common denominator. Okay. Well, why did this help me? Because, see, now I can cancel. So the sines will cancel. That leaves me 1 over cosine minus. What happens over here? Cosines cancel. So that leaves me 1 over sine of x. And then maybe now we go ahead and use an identity. What's 1 over cosine? Oh, not tangent. That's secant. That's one of my, what do we call that identity? It has 2 names. Starts with R, ratio, or the quotient identity. There we go. So secant of x minus, what's 1 over sine? Cosecant. Cosecant of x. Okay. And I'm looking through my answers. Is there an answer that says secant of x minus cosecant of x? In fact, we do have it. Which one is it? It's M. See, secant of x minus cosecant of x. So that tells me 23, okay, was answer M. So every 23 that I see here, I'm going to replace with M. I got an M here. Let's see, am I missing any other 23s? I don't believe so. So is everybody also okay with how to decode the message? Okay. All right, that is 2. Nope, I said 3, so there's 1 more. Which one would you like?
What if we chose one of the answers and you worked the problem for us that it goes to?
Well, technically, I kind of am working the problem for you, though.
Yeah, no, like.
Oh, you're wanting me to just tell you.
No. I was saying, like, what if we choose the answer and then you work the problem that it goes to?
We are going to get to a point, in fact, next week, where we're going to start looking at equations, and we're going to get to choose what side we want to start with. So we could potentially start with the answer and work backwards. But I'm going to go ahead and wait on that idea. Okay. So 24 left to choose from. Or do you feel you're good? 15. Okay. Cotangent squared over cosecant plus 1. Is that which one you guys want? Okay. Sounds like a good one. Cotangent squared over cosecant of x plus 1. Okay. Now, there's a variety of ways we could approach this. I've already got two possible ideas. If your denominator is a binomial, what am I talking about binomial? It's got two terms, right? You could go ahead and multiply by its conjugate, cosecant of x minus 1, cosecant of x minus 1. That will work. Okay, so that's one possibility. The other way I'm thinking is to go ahead and rewrite everything in terms of sine and cosine. Okay, so let me kind of set that one up, and then I'll let you guys decide what you want to do. What is cotangent? It's what over what? It's cosine over sine. So cotangent squared would be cosine squared over sine squared. Okay, we're going to keep that square. It's going to go all the way through. Over. Now, cosecant, what's the reciprocal? Okay, 1 over sine. And then plus 1. So my thinking here on this other idea would be to combine 1 over sine and 1 into one fraction and then multiply by its reciprocal. Okay. Personally, I'm kind of thinking of the two. This might be easier, but I will do whatever you guys would like. You think this one would be the best way to go? Yeah. Okay. All right. Well, let's continue. Now, think about it like this. I want to take 1 over sine of x plus 1. So that's the same as 1 over 1, right? What do you think the common denominator would be? It's got to be sine. Okay. So I'm going to go ahead and multiply that one by sine over sine. So really that makes sense. Sine divided by sine is just going to be 1, and that's what we're looking for. So I've got cosine squared, okay, of x over sine squared of x divided by. So what I have here is 1 over sine of x plus sine of x over sine of x. So what's it going to be if I combine those two? There you go. And, the order doesn't matter. So 1 plus sine x or sine x plus 1 over, and what would the denominator be? Now, would it be squared? It would just be sine of x, right? Because remember, when you combine using the same denominator, the denominator does not change. Okay. So now, I'm going to multiply by the reciprocal. So I'm going to have the cosine squared of x over the sine squared of x times sine of x over sine of x plus 1. Is everybody okay with what I did? Okay. So now what? Okay. So I can cancel out one pair of sines. Okay. Now, I think I know where I would go from here, but where would you guys like me to go? Because I'm already seeing something that I can do to cancel. Sine x and the other sine x. No, because this is sine x plus 1. And remember, we're multiplying these. Okay. There is an identity that I'm noticing. Okay, the Pythagorean. We've got cosine squared, right? Now remember, we have an identity that says sine squared plus cosine squared equals 1. So is there any way to rewrite this so that it equals cosine squared? Okay. Subtract the sine squared over. Those cancel. So cosine squared of x equals 1 minus sine squared of x. So because this is true, I'm going to substitute 1 minus sine squared for cosine squared. I'm just going to plug it right in. 1 minus sine squared of x over sine of x is equal to 1 over, well, excuse me, times, sorry, not equals, sine of x plus 1. Okay. Now, we can't cancel out. There's something you need to notice. Does anything look familiar? It's all sines, that's true, but I'm talking about this guy right here. He's a what of what? Difference of squares. Okay, so right now he's in the form a squared minus b squared, right? If I were to factor it, that would give me a plus b, a minus b, right? So what would that be if I factored it? 1 plus sine x, 1 minus sine x, all over sine of x times 1 over sine of x plus 1. Now, why was that good? See, because now 1 plus sine x plus 1, those can cancel. Ooh, this was a good problem to choose. This might be the biggest one on there. Okay. And actually, I'm already seeing what the answer is. 1 minus sine of x over sine of x. Well, we don't see that answer in my key, right? Does anybody remember what was the trick I did just a moment ago to help with the very first problem? Or maybe it was the previous one? If you're going to combine fractions, you need a common denominator. But that rule is reversible. So I could say 1 over sine of x minus sine of x over sine of x. Well, what's 1 over sine of x? That's going to be cosecant minus what? 1. And is that one of my answers? Yes. Ooh, that was a good one. In fact, what letter is that? That one is J. Cosecant of x minus 1. Good. So everywhere I have a, what number was that? Was it 15? So everywhere I have a 15, we're going to have a J. Okay, so let's see here. 50, 50, 50, 50. Am I missing a 15? Is there no 15 on here? Am I not seeing a 15? Oh. So it looks like that one we got experience on that one, so doesn't help me with the key though. That's pretty awesome. I like that. I wouldn't say useless. See, it goes to show that, you know, unfortunately not all of them are going to be just 1 or 2 steps to get to the answer. And could there be a method that's a lot faster than what I did here? I'd be kind of interested to see what the conjugate did, but I mean, we just took it 1 step at a time. Okay, and the important thing on these problems, you know, is don't give up. Okay, if you do start to feel frustrated or you're not sure if the method you have is going to work out, you know, go back and try something else. Okay, but if you stick with it, it will come out in the end, as long as you're following those rules. Keon. As long as you decode the message, I'm okay with that. Okay. There you go. So it was a great problem. Unfortunately, did not help with the decoding, though. Okay, so he's looking through. He says there's no number 6.
There's no 10, there's no 13.
Okay. So if I take a look, like number 6, though, okay, number 6, that would be pretty easy to solve, though, right?
There's no 8.
In fact, what would number 6 equal? It would just be 1, yes. Because remember, we have an identity that says 1 plus cotangent squared is equal to cosecant squared. So if I want cosecant squared minus cotangent squared, I just subtract that over, yeah. So 6 would be B. But like you said, it's not 1 on the decoding. So actually, I did 4 for you, so there you go. All right. So any questions? And like I said, if you don't want to do this, you don't have to. It could be worth 10 points on your exam. It could take care of 1 question that you miss. Okay. So if you want to finish this, bring it back tomorrow. That'll be your bonus on the exam. All right. So let me go ahead and shut this down. If you want to save changes, why not?